So today's webinar is Managing Technical Debt with Keyone Action Plans. My name is JD Burke. I'm a sales engineer with Keyone. And joining us today are actually doing most of the heavy lifting on this webinar will be Eduardo Boronat from our Spain office, our Madrid office. He's as you can read there, a DevOps engineer with Keyone, among other things. He does quite a few things for Keyone. The agenda for today, we'll do a very quick short introduction of Keyone and SAST. Then we'll start to look at running an analysis with our on-premise agent called the Keyone Local Analyzer. Then Edu will help us understand the results of that analysis. He'll show us how to create an action plan, which is the Keyone term for a to-do list when you create or when you uncover vulnerabilities within Keyone. And then he'll show us the difference between action plans and what ifs, are a tool that we have to help create action plans easily. He'll fix some vulnerabilities with the Keyone Eclipse IDE plugin and show you some of the power that's built into that part of the Keyone tool set. And then he'll check on some of the action plan progress, and then we'll wrap up with any questions that we have in our list. All right, so what is Keyone? Keyone is a SaaS, a cloud-based SAST and SCA tool, so static application security testing and software composition analysis. We refer to it as a hybrid because it's actually a dashboard that shows results in the cloud, but an on-premise agent that's built in Java, so it's very portable, lightweight to deploy, and that gives you the ability to do your analysis with code on-premise and not have to ship your code off-premise. But then the power of the cloud so that we can augment all the results and fold in additional metadata about what we found in your code. And then there's also some tools that allow you to manage those vulnerabilities and that tech debt that we helped uncover. Today, we're going to be focusing on SAST, Static Application Security Testing, although we do ISO 25000 software quality version of this and SCA, software composition analysis. Today, we're going to restrict or confine our analysis or our talk to just a plain and simple SAST use case. So as I said, our hybrid solution is a combination of SaaS and an on-premise component. So we analyze the code locally on your premise with a Java application called Keyone Local Analyzer. That Keyone Local Analyzer uploads the results of the scan, not the source code itself, but the results to our cloud. And then we augment that and provide that back to you in a dashboard at keyone.com that's private to you and your organization. And then from there, you can create a series of action plans or what might be referred to as a to-do list. And then you can push that to-do list out to things like Jira or whatever your task tracker is and assign resources to that task, that action plan to work the task. So that's Keyone in a nutshell and what we're going to be talking about today. So at this point, I'd go ahead and hand over control back to Edu and Eduardo Boronat and say, buenos dias, Eduardo.
Thank you very much, JD. Good morning. So what is an action plan? A Keyone action plan is a set of vulnerabilities that you can assign to developers to work on, so they can remediate the vulnerabilities that are within an action plan. So this is the process that we are going to follow today. First of all, we will analyze with Keyone Local Analyzer a vulnerable web application called JuiceShop that was developed by OWASP. Once the results are uploaded to Keyone, we will generate an action plan. And after that, we will get the action plan from Eclipse through the Keyone IDE plugin as if we were the developers. Here we will remediate some vulnerabilities, and finally we will analyze again So we will see in Q1 platform the progress of the action plan. This loop here can be repeatedly done throughout the application lifecycle. So with Q1, you can bring security earlier in the software development lifecycle. This practice intended to find and prevent vulnerabilities early in the software delivery process is called shift left. So the idea is to improve security by moving tasks to the left as early in the life cycle as possible. So the previous process can be introduced into design, coding, and testing stages. This graph here shows what we are trying to achieve. So we are finding vulnerabilities in the early stages, number 2, 3, and 4. So the cost will be within this interval, which is quite lower than finding a vulnerability in the last stages. Well, so let's go to the practical part. First, we are going to analyze the GSOP web application with the Q1 local analyzer. You can download the Q1 local analyzer from Q1 administrator panel from here. Download Q1 local analyzer. And once you have unzip it, you can run, well, you can run the q1.cmd that I have it in my desktop. So Q1 local analyzer here, q1.cmd. And make sure you have a Java runtime environment on your computer because this is a Java applet. Let's go. You log in with your Q1 credentials. And now you will select your application. GSOP, GSOP appears here because I have it already created here in Q1. You can create new applications with this button. And the source code of my application is here in my desktop. This is the source folder. So we will do a baseline analysis. This is version 1.0, and we continue. We are interested in code security, which will find the vulnerabilities in our application. If we click on the options button, we will see that my application is composed by 52 HTML files and 260 JavaScript or TypeScript files. So those are the ones that are going to be analyzed. So we click on Analyze, and we wait for our results to be automatically published in our Q1 account. I have already done this analysis, so we can see here the results. You will see, when you analyze with Q1, you will see a screen like this one. So here you can find out what is the security rating of your applications. It goes from 1, less secure, to 5 stars, the most secure. So if you have just one vulnerability with very high priority, Q1 will score your application with only 1 star, because in Q1 we consider that having a very high vulnerability could be critical for your business. Then you can see here what vulnerabilities put you at a higher risk based on the likelihood of them being exploited and the impact an attack may cost. And here you will know the effort you have to invest to improve your security rating. So in my application, if I want to achieve 2 stars, I will have to invest around 6 hours. You will know how many lines of code your application has, how many files, and how many vulnerabilities. See at first glance what kind of vulnerabilities your application is exposed to and the top 10 files with the worst ratings. Now we are going to the Files tab. Here you will see information per file. So you see the security rating per file, the lines of code, the number of vulnerabilities, and the priority distribution of the vulnerabilities. So for example, this file here has 6 very high vulnerabilities, and the effort you have to invest to remediate all the vulnerabilities in that file. And now we are going to the most important tab, the vulnerabilities one, where you will see all the vulnerabilities that were detected by Q1. So for example, in our GSOP application, we can see that Q1 detected 2 SQL injection vulnerabilities. If we click on the vulnerability, we will see that one is in the login.js file and the other one in the search.js. So it seems like that in the login form of the GSOP application, an attacker could retrieve information from the database. So if we click on that, we see the sink and the source. So we see here the query that is executed into the database. This is the line of code of our application. So let's exploit this vulnerability. So you can see how an attacker could retrieve information or access to your application thanks to a vulnerability like this one. So for that, I have here in my computer the GSOP web application. I have to deploy it locally, so in localhost. So I'm going to deploy it. Here it is. And we start the application. All right, now the application is listening on port 3000. So we go to localhost 3000, and this is GSOP application. This application is the insecure web application developed by OWASP, and here you can buy some products, some fruit juices, shirts, some products. So we go to the login page, where Q1 was telling us that there is an SQL injection vulnerability in this login form. So this is the login form, and let's exploit the vulnerability. As email, we can introduce whatever. I will explain later how this was possible. So whatever, a quote to close the first, like the email, and then we can put or, true, and 2 hyphens, which means comment everything in the query to the right. And as password, we can introduce whatever. I don't mind. We log in, and let's see what happened. In account, oh, we are the administrator. We are logged as with the administrator account without knowing neither the username nor the password of the administrator. So this is a very, very dangerous vulnerability, and I'm going to explain how this was possible. I open a notepad here, and let's see what happened. I'm going to copy here the line of code where Q1 detected the vulnerability. That is this one. All right. And now I'm going to build the query that was really is executed into the database. It was select everything from table users where the email is equal. We have to copy here this quote. And then this here is replaced by what I introduced into the email field of the login form. That was whatever, a quote. This quote here is not this one, is the one that I introduced into the form. Whatever or true and 2 hyphens. Now it goes this quote here and password equal the quote, and this here is replaced by what I introduced into the password field of the login form. That was whatever. We close it with this quote, and I don't mind the rest, the remaining part. So what happened? That here, as you can see, I introduced a quote and 2 hyphens. These 2 hyphens here means that in SQL language, comment everything that is on the right. So this here is not useful anymore. And now the final query was select everything from users where the email is whatever or true. But this or true is going to be always true. It always is satisfied. So finally, this query returned a list with all the users of the application, and probably the application took the first returned one, that was the administrator. So now we are going to the action plans tab, and there are 2 types of action plans. New action plan, to create a new action plan manually, and what if, which opens a simulation tool and let Q1 choose the most important vulnerabilities depending on the available time that you have to remediate them, or depending on the security rating, that is the number of stars that you want to achieve. So let's create one per type. So first of all, we are going to create a manual action plan. We will select the vulnerabilities that we are interested in. So for example, the first 3 that are the ones that the developers will fix or remediate. And we save this action plan. As name, we can introduce a manual action plan of Edu. And we assign these action plans to me. Save. As you can see here, the progress is 0% because we haven't already fixed any vulnerability. And now we are going to create an action plan with the simulation tool. So here you can write, I have 20 hours to invest remediating vulnerabilities. So when you click on simulate, Q1 will tell us which are the vulnerabilities that you can remediate in this period of time. As you can see here, in 20 hours, you will be able to fix all the very high vulnerabilities. This is before, and this is after completing the action plan. Or you can select rating So you say, I want to reach 2 stars. Q1, tell me which are the vulnerabilities that I have to fix. And these are. So as you can see here, 11 that are all the very high vulnerabilities. We save this action plan. So this is an automatic action plan. And we assign it to me. Save. All right, so now what we are going to do is to download this action plan from our IDE, which is Eclipse, through the Q1 IDE plugin, also known as Q1 for developers. So I'm interested in the manual action plan, so I'm going to delete this automatic action plan. And let's go to our Eclipse. Well, here you see that this is my GSOP application with my source code. So the first step is to install the Q1 IDE plugin. For that, you have the steps in our documentation, but it is from here, from install new software. After that, you will have to go to preferences. There is here in the menu a Q1 tab, and in connection settings, you will have to set your Q1 username and your password. If you are using proxy or a single sign-on, you can configure it here. Okay. Now the next step is to say, all right, this project, I have to convert this project to a Q1 project. For that, we right-click in Configure, Convert to a Q1 project. So you will see this screen where you have to select with which Q1 application this app is linked. So with GSOP, these are my Q1 applications with GSOP. Apply. Do you want to be able to perform analysis automatically? No, we will do it manually. Now we will have to display here 2 new tabs. For that, we will go to Windows, so View, Other, and we select Defects Local and Defects Server. Here we are. So a Q1 IDE plugin for Eclipse has 2 modes. The Viewer mode, which is related to the Server tab, and the Analyzer mode, which is related to the other tab with the local one. So the Viewer mode, that is here in this tab, allows you to download vulnerabilities from Q1. So if we click on this button, well, I have to select the project. We click on this button. We can download from Q1 the last baseline analysis or the action plan. We are interested in my action plan. So as you can see here, this is the action plan that we have already created. Manual action plan of Edu. Okay. And these are the vulnerabilities that was inside this action plan. You can filter these vulnerabilities here with this other button that is filter here locally. And now in the analyzer mode, you also have these 2 buttons, but now this is for filtering the analysis. So with IDE plugin in the analyzer mode, there is an embedded engine, Q1 engine, that will detect your vulnerabilities in your source code inside your IDE without analyzing with Q1 local analyzer. So everything inside Eclipse. So it is a good practice to select and to play with the filters so you can see the same vulnerabilities here and here, because here you will know which vulnerability are in your action plan. And from here, you will see if when a developer fix this vulnerability, it has disappeared or not, because maybe the developer fixed it in the wrong way. So Q1 detects that the vulnerability already exists. So let's, for example, remediate these three here, three vulnerabilities related to the eval function. So we are looking for them in the local. So they are here because I filtered by priority very high and characteristic security. So I found them because here there are very high and security. So if I double click on it will go automatically to the line of code where the vulnerability was detected. So the developer can remediate it. If I right click on it, I can see more information about this vulnerability. So the developer can see how to remediate it because there is an example of violation code, a fixed code. And this vulnerability is related basically with cross-site scripting attacks. So if you use the JavaScript eval function, an attacker could carry out a cross-site scripting. So it's important to remediate it. All right, so let's remediate these three vulnerabilities just by removing the eval function. And when we save the file, look at it, because it will disappear if we have fixed it correctly. Well, it disappeared. So we have fixed one vulnerability. There are only two remaining. Let's do the same process here. Don't use eval function. We save. And the last one, don't use the eval function. Great. As you can see here, they disappeared, but because of the analyzer mode. But if you go to the server tab, they are here. They are already here. So if you want them to so the next step is to analyze with the Q1 local analyzer. So the results are uploaded to Q1, and the next time you upload your action plan, this one and this one will not be here. So let's analyze again with Q1 local analyzer. I want to analyze GSOP. This is my source code. All right. So version 2.0. We continue, and we are interested in code security. Analyze. The analysis will last for around 1 minute. So meanwhile, I'm going to show you another option of the IDE plugin. So there is another Q1 tab. So in Windows, so View, Other, which is called Metrics. So you can obtain from here the metrics of your project. For that, you will have to activate from Window Preferences, Q1. In Analysis Options, you will have to check this option, Extract Metrics. Apply. So the next time you analyze locally, you will see here the metrics. You can analyze manually by double clicking, so right clicking here and run Q1 analysis. So you can see here that it is analyzing according to these filters. Well, the analysis is finished, so let's go to Q1 and see the results. Here we are, version 2.0, and if we go to action plans, we can see that there is a progress in our action plan. If we click here, we see that the action plan was created with 11 defects. There are 8 pending defects because we didn't remediate them, and we removed 3 defects that are the ones related to the eval function. So by doing this, we can add Q1 in our software development lifecycle by finding vulnerabilities at the same time that we are developing our application. All right, so that concludes the presentation. You can write now all your questions in the chat, and my colleagues and I will be glad to answer all your doubts.
So Edu, this is JD. I have a couple of questions that have come in, if you'll be so kind as to help me.
Yes, sure.
The first question was, does changing the code in the IDE start an instance of KLA and reanalyze the code locally? So I think they're referring to the defects local changes. So when you change the code, we saw those entries get removed from that tab.
An analysis is locally done, so the results are not uploaded to Q1, but you will see in your IDE that that vulnerability has been fixed or not.
Excellent, thank you. Another question I think is related, and I think you might have answered this one as you were speaking. Does the local analysis or the changes that you made in the IDE update the server analysis? And I think the answer to that is no. I still need to go run a new baseline. Is that right?
Yes, that is right. You have to run a new baseline analysis with Q1 Local Analyzer. So the next time you download an action plan or your baseline, this vulnerability will not be there because it is fixed.
Okay. Another question is there a way to automatically create a new baseline from a past audit? We didn't speak about this directly, so some of the listeners may not know what we're talking about here, but when you scan a code, you can run it through our audit function and check points, and that's what populates helps populate the life cycle and action plan stuff that Edu was looking at. And this is kind of a corner case, Edu, sorry about this, but is there a way to automatically create a new baseline from a life cycle scan that passes?
No, action plans are only created from code security and code analysis modules.
Okay, very good. All right. And I have another question here, which is which version of JDK do we support? So the KLA is Java 1.8, correct?
Yes, it is 1.8. It's the recommended version for using the Q1 local analyzer.
Right. But the actual Java, our Java analysis is supports many more versions, correct?
Yes, it is correct. But the recommended one is the 1.0, 1.8, sorry.
For the KLA.
Yes, for the KLA.
Yeah, but if I'm analyzing Java code, I can, if I write code in Java and I want to scan it with Kiwan, I can, there's many more
yes,
versions.
Yes, I thought you were talking about the Java that is in your environment variables, but Q1 analyzes any Java version, any application built with any Java version.
Yeah, very good. And you understood correctly. I was just making sure I understood correctly. All right, so you did well. You answered all the questions that I have stacked up. So the question here, Edu, if you don't mind, I'll take this one. The question reads, what is the license model? So Kiwan charges by lines of code. So some of our competitors will charge based on per seat or applications, and Kiwan factors by lines of code. Yep. And then another question, can we see the panel on the cloud? So I'm not sure exactly which panel we're talking about, but if you're talking about the panels in the IDE, then no, because that's IDE based, obviously. But perhaps, Edu, you can bring up your dashboard again, the kiwan.com, and show them,
Yes.
for example, where action plans are.
Here?
Yep, correct. And then we have a follow-on question that it's only based on the OWASP top 10, and no, that's not correct. We do much more than OWASP top 10. So Edu, if you'd be so kind as to click on rules management in the administration panel.
Yes, in models management,
Models management,
you can
sorry.
see
Then
all
go to
the
rules.
that Q1 supports.
Yeah. And while Edu's doing this, what you're going to see is we do much more than just OWASP top 10. We do about 13 or something like that under the normatives. So you should
can see here some normatives and, for example, OWASP, and you will see all the rules related to OWASP. There are 700, so they are a lot.
Yeah. All right. So Edu, I've got a favor to ask of you. One of the watchers is asking more about the severities and setting severities manually, and the severity matrices. So this would be under code security, the very high to low, that kind of concept. And specifically when we do a scan in our IDE, setting those filters to filter for very high, normal, and low scans.
Yes, you can filter in your IDE here in the button that downloads every vulnerability. You can filter here by priority, by characteristic, language, file pattern. So you can do everything that can be done from Q1 local analyzer. Every filter, it is also possible here.
Very good. And if you happen not to agree with the severity or the time budget that we've allocated for a given task, you can change those. Those are user configurable by the end user. But right out of the box, we give you our best guess. So unfortunately, we're coming to the end. So I'm on my final 30 seconds here with Edu. So I'd like to try and use that time to, once again, thanks Edu for helping us actually use Key1 to do good work. And thank
you.
everyone who listened, who joined in with your questions. I appreciate that. And then remind everyone to be safe. And if you have any more questions or comments, to contact us via our website. So once again, thank you.